Hey guys. All right. We're going to look at 6.4 part 1. It's all adding rational expressions. And so let's practice adding fractions in general. If you're going to add or subtract fractions, they need common denominators. So I will take my fifths and my 2/3. I'm going to multiply them by my fancy number 1. So like 3/3 is 1. I strategically chose 3/3 because 3 times 5 is 15, and I can multiply by my fancy number 1 over here of 5/5 is 1. And again, I have a 3 times 5, I have a 15, so they will have common denominators. So those will turn into, here, I'll have to write it up here, they'll turn into, multiplying straight across, a 3 times 2, so 6/15, plus, and then my 2 times 5, so 10/15. And when I add or subtract, that common denominator will come along for the ride. We are just going to add the numerators. So I'm just going to add a 6 plus 10 for 16. If I could reduce the fraction, I would, but that's as good as it's going to get. On number 2, they already have common denominators for me. That's nice. So I am going to, again, add just the numerators. So my 1 plus 2 is 3 over that common denominator x, and that actually is done. On number 3, they do have a little something similar there. They both have an x. The second denominator is 2 times x. The first denominator does not have the 2. So again, I'm going to multiply by my fancy number 1, which you can multiply by 1 all day long. It's not going to change what it's equal to. It will change the way it looks though. So this is going to give me my multiplying straight across. 2 times 1 is 2, and 2 times x, so 2x. So that's the first fraction. Plus 1/2x. All right. So now, again, my answer will have that common denominator of 2x. I will just add the numerators. So my 2 plus 1 is 3. Okay. Number 4. A lot of people think that they do have something in common, that I just have to like put a -1 onto the other fraction, but that's not true. All the blue stuff, all the multiplying by my fancy number 1, I again was multiplying, not subtracting a 1. So I have to multiply my first fraction times the other denominator. That x I put over itself, so x over x. And then the other denominator, x minus 1, will be multiplied to the other fraction, x minus 1 over x minus 1. Now both denominators have an x times x minus 1, x times x minus 1. So since they both have x times x minus 1, let's look at the numerators. X times 1 is x, plus 1 times anything is itself. So 1 times x minus 1 is another x minus 1. Okay, so I think the best I can do is simplify the numerator. X plus x is a 2x minus 1. I am okay with you leaving the denominator factored. Read the instructions on the homework though, or the test. If they tell you to put it in standard form, then you would have to distribute. This one did not specify what form they want, so I'm going to leave it in factored form. Okay, number 5, very similar to number 4 in that the denominators are not the same, so I have to multiply by this other denominator, x minus 2, over another x minus 2. Again, the reason why I can do that is because anything divided by itself is 1. So I really am multiplying by 1. And multiplying by 1 doesn't change anything. So this other one's going to multiply by, again, my fancy number 1. It is the other denominator over itself. So x minus 1 over x minus 1. Okay, so now my denominators, x minus 2 times x minus 1, x minus 2 times x minus 1. Okay, so I'm going to put that as my common denominator. Let's see here. X minus 2 in parentheses times x minus 1 in parentheses. Okay, I do have a little something extra here. I guess I could have distributed a 1 on that side. Multiplying by 1 though doesn't change anything. Here I gotta especially make sure I multiplied the x times x for an x squared, and the x times -2 for -2x. And then I've got this addition. I am adding that to my other polynomial, which I then have to distribute again. So a 3 times x minus, and then 3 times 1. All right, so let's see, I can combine some like terms, these guys. My negative 2x plus 3x is a 1x. So I can get x squared plus x minus 3 over, and again, I'd be okay if you leave in factored form. In fact, I think that helps us see if we can simplify later on, but for now, I'd be okay with that. Okay, for number 6, again, I will do the other denominator, the x plus 1, over itself. And that will multiply by my first fraction, the 2 over x squared, plus, and then my second fraction is going to be multiplied by my fancy number 1 again, but that is coming from the other denominator. It would be an x squared over x squared. Okay. It looks like both denominators, x plus 1 times x squared, x plus 1 times x squared. So usually I put the x squared first, but that's just what I would do. And then I will have to do, like I did on the last one, distribute. So my 2 times x and 2 times 1. Then I've got this big old addition in the middle here, so plus, and my 5 times x squared. I guess I don't really have distributing here. I just needed to do 5 times x squared. As far as simplifying goes, I don't think I can combine any like terms or anything. Maybe I could rewrite it in standard form. I can go from like highest exponent to lowest exponent, but that's pretty much all I got. Okay. All right, so then let's see if we can step it up a notch. Number 7, you've got 3 different fractions. And so far, our denominators have all been factored. I do think on number 7, this last denominator is not necessarily factored. So let's factor that first. Okay. So I think I always start factoring with the GCF, greatest common factor, and I think this does have a GCF. It has an x, so I'm going to factor out my x, and I'm left with x minus 5. All right, that helps me because now when I look at each denominator, I'm looking at this x, plain x. This other one, x minus 5, does not have the plain x. So I'm going to multiply this by x over x. I need some space. Maybe I'll rewrite it down here. So yeah, that x, I got to multiply x over x on my second fraction. This actually, the third fraction already has the plain x in the denominator, so I do not need to multiply x over x onto my third fraction. So that was the denominator of my first fraction. Let's look at the denominator of the second fraction. The second fraction had the x plus 5. Here, maybe I'll underline it. Okay, so this one already had the x. I had to add it to the middle one. This one already has the x now. Okay, so green stuff, the x minus 5. Middle one has the x minus 5. Actually, the last fraction also has an x minus 5 in the denominator. So I need to multiply by x minus 5 over x minus 5 on my first fraction. That's the one that did not have the x minus 5. Everything else does though. So now all 3 fractions have an x times an x minus 5. So that will be my overall common denominator. Okay, so this first fraction, with all those parentheses, I have to distribute my 2 to each of them. 2 times x, 2 times negative 5 is a negative 10. Okay. And then plus the numerator in my second fraction. I don't think I have distributing. I have to multiply a 3 times x, but not really distributing. So there's my 3x. And then plus, again, nothing here. It's just a straight up x. That's nice. Okay, so the last bit, I'm going to combine like terms in the numerator. It looks like I've got a 2x and a 3x. 2 plus 3 is 5, so I'm down to a 5x in the numerator. Oh, and I have another x as well. So I'm up to 6x. Okay, all right. Constant -10. All right. X minus 5 in the denominator. All right, I might like to factor my numerator. Here, I'll put an arrow, I'll write it up here. I would probably factor my numerator, like a GCF is 2. I'm left with 3x minus 5. That might help me. Say I factor and maybe these were both an x minus 5, I could divide them out. That's what I would need to do to simplify. As of right now, I don't have anything that can divide out, so I would say either of these are the correct answer. One is factored, one is not. All right, number 8. I think you guys saw these with polynomials before where they didn't write it as a fraction and I considered it over 1, like 2 over 1 to see it as a fraction. And when looking at the denominators, denominator of 1 does not have the denominator of 2x plus 3, so I think I'm going to multiply this 2 over 1. I'm going to multiply it by the 2x plus 3 over 2x plus 3. All right, my second fraction, x squared plus 1, okay, over 2x plus 3. As far as the other denominator goes, the 1, I guess I didn't write that it has a denominator of 1, but this really is multiplied by 1. Do we really need to consider the whole multiplying by 1? Not necessarily. So both these common denominators should be 2x plus 3. Technically 2x plus 3 times 1, but I'm just going to rewrite it in the simplified form, 2x plus 3. All right, and then I will distribute for 4x plus 6. And I am adding the other numerator, adding my 9x squared plus 1. All right, so if I combine my like terms, I think I've got a 4x, no other plain x's, nope, 6 and 1. Okay, I can combine those for a 7. My 4x had nothing to combine. My x squared, I think I only have one of those. It's the 9x squared. Okay. And a 2x plus 3 in the denominator. Okay. So all the blue and green stuff actually were me multiplying by my fancy number 1 to get common denominators. All of my purple stuff was distributing just in the numerator. Notice I did not have any purple stuff in the denominator. I distributed what I needed to in the numerator. And yeah, that's what we have so far. So let's go on to number 9. Find the least common multiple of 4x squared minus 16 and 6x squared minus 24x plus 24. The least common multiple, I'm going to need to know what the factors are. So let's brush up on factoring. This one, let's see, does it have a GCF? Yeah, I think I've got a 4 I can factor out. So x squared minus 4, all right. And then in the middle there, I've got only 2 terms. So I'm thinking I might go to one of the formulas. In fact, I think this is going to be the difference of squares formula. A squared minus b squared equals a plus b times a minus b. So as far as my x squared minus 4 goes, I think I'm going to treat my 4 as like a 2 squared. So my a and my b, I have an x squared and I have a 2 squared. So instead of a plus b, I've got x plus 2. And instead of a minus b, I've got x minus 2. Don't forget this 4 though. A lot of times people kind of eliminate that. Bring that 4 along for the ride. And I think that one is factors as much as possible. So let's go on to the next polynomial, starting again with GCF. So let's see here. My GCF for 24 goes into 24 and 6 evenly would be a 6. So if I factor out my GCF, there we go. And then again, I usually ask myself, Well, how many terms are there? There are 3 terms. And what's my leading coefficient? This is like a 1x squared. So I can do the whole what multiplies by the last number adds up to the middle. So to multiply to be +4, add up to -4. I'm thinking -2 times -2 is +4. -2 plus -2 is -4. Okay. And there are my x's. Again, bring that 6 along for the ride. Draw a little line here. So we factored both of them, which means that helps me find the least common multiple. The least common multiple is going to be something they both go into evenly. And what do they both have as of right now? Let's see. They both have at least one of the x minus 2s. All right. As far as the other x minus 2 goes, the one on the left does not have the other x minus 2. So I'm going to put this other x minus 2 there. All right, now they both have x minus 2s. They both have the twice. They have x minus 2 written twice. Okay, what else do I have to do? The 6. 6 compared to 4. What is the least common multiple of 6 compared to 4? So what does 6 go into evenly and 4 goes into it evenly? I'm going to go with, let's see, 12? I think I'm going to go with a 12. A lot of people go with 24 because 6 times 4 is 24. But I think I'm going to go with a 12, and it'll make things so much easier in the future if you know how to get the least, the smallest number that they both go into evenly. Okay, so let's see, am I running out of colors here? There we go. As far as the constants go, I'm trying to do 12. 4 times 3 is 12. Okay. And then 6 times 2 is 12. Okay, so as far as the constant goes, it's the least, like the smallest, and common. They both equal 12. So least common multiple. And I think the only thing I haven't underlined yet was my x plus 2. And I have it on the left side. I do not have it on the right side. So I'm going to put my x plus 2 in here. So now, least common multiple, it's the smallest. I could have that they actually are totally the same polynomial now. I haven't distributed the polynomial or anything, but I think they all have the exact same factors now. And I think that will be really helpful on number 10. So did you notice that those denominators we were just looking at, 4x squared minus 16, that's the same as this denominator. And the other polynomial we were just factoring, similar to the other denominator. Okay, so the reason we were looking at the denominators is this will help us getting a GCF, not GCF, common denominator, that's what I was going for. Okay, so what I'm going to do here, obviously you can see there's a lot of space for a reason. You're going to do 1 over, and what I had in factored form, this stuff, was my 4 times x plus 2 times x minus 2. That is the factored form of the original denominator. I factored out a 4 GCF. I did the difference of squares. This is what I got. I didn't add anything to it. And then plus 2 over, again, the stuff I had in black here. Before I add anything onto it, it was factored into a 6. X minus 2 times x minus 2. In other words, x minus 2 squared, but yeah. So these were the original factored forms, the ones that I underlined. Those were originally the polynomials just factored. What I added on to them, though, the first one, this stuff over here, I added a 3, so I have to do my fancy number 1, 3 over 3. And I got to do my fancy number 1 with the x minus 2, so x minus 2 over x minus 2. Okay, so now I have all this stuff that we were going for on the first fraction. The second fraction, I'm going to multiply by, again, the stuff that I had to do before, 2 over 2 and x plus 2 over x plus 2. Okay. So now they are common denominators, as messy as they are. They both have the constant, so 3 times 4 is 12. This other 6 times 2, also 12. Okay. They each have an x minus 2, another x minus 2, another. So they each have 2 of the x minus 2s. So in other words, x minus 2 squared. X plus 2, they both have an x plus 2. Okay, so they are common denominators now. Let's look at the numerator. 1 times anything is itself, so I'm not too worried about that 1. The other stuff, though, I do need to distribute the 3. So 3 times x and 3 times negative 2. Over on the right side, this fraction, 2 times 2 is 4. And I have to then distribute that 4 to the other polynomial. So I get a 4x plus 8. All right. So now that they have common denominators, as messy as they are in common. Bring that denominator along for the ride. Numerator is what I actually have to add. So 3x plus 4x is 7x. My negative 6 plus 8 is a positive 2. Okay, so that's what I get up in the numerator. If I could factor this any further, I would, but I think this is as good as it's going to get. Okay. So notice what I did on number 9. Finding the least common multiple helped me get my common denominator. So let's do that on number 11. Let's find, I'm asking myself, what's the least common multiple between these two denominators? And just what I did on number 9 here, I factored first, and then I saw what factors each of them were missing. Okay, so that's what I'm gonna do here. I'm gonna factor them all first, which as far as the 9x squared goes, I guess the best I could do is break it down to like 9x times x, maybe a 3 times 3 for a 9. I don't know, I think that's as good as I can do. I can break it down really no further than that. The other denominator, let's do a factor here. Here, I think I usually start with GCF. So I think what they have in common is a 3 and an x. So once I factor that out, I have left a single x and plus 1. And if I could keep going, I would, but this is a plain x. It's not x squared or cubed or anything like that. So I think this is as good as it's going to get. Let's look and see what they have in common and what they are missing. I think they both have a single 3 and an x, at least one of those x's. But this other 3, I don't see a second 3 over here. So I think what I'm going to do is take that second 3, I'm going to multiply my second 3. The other x as well, this one has 2 different x's. This other one, it had 1 x. This one does not count. That's an x plus 1 altogether, package deal. I'm looking at things that got multiplied together, and I was multiplying by another plain x. Okay, so that means everything in the left denominator is taken care of. Let's look at the right denominator. The 3s are taken care of, the x are taken care of. X plus 1. I have an x plus 1 factor in the second fraction. I do not have an x plus 1 in the first. Let's multiply x plus 1 over x plus 1. And you know what I didn't do correctly? I multiplied by, see the yellow, the 3? I was supposed to multiply that in the numerator and denominator. Same thing for my x. Multiply by x in the numerator and denominator. And there we go. The original fraction had a 7 in the numerator. The other original fraction had an x in the numerator. So let's see, common denominators. Let's simplify these things. Man, they look pretty long. Let's see. It was outside of the parentheses, I think looks like a 3, not a 3, a 9x squared. Inside the parentheses is an x plus 1. The other denominator also has 3 times 3, so 9, x times x, so x squared, and the x plus 1. So I think they have common denominators now. The numerator of my first fraction is going to have a 7 times x and a 7 times 1. The numerator of the second fraction looks like a 3 and then 2 separate x's multiplied together, so x squared. There's my 3x squared. All right, so now, since they have that common denominator, I'm going to bring that denominator along for the ride and add the numerator. So there's only a single x squared, no like terms with that. Plain x's, I think I only have the 7x, no other like terms to combine it with. And my 7, I think that's as good as it's going to get there. So these ones. Okay, I added my fractions together. And then the last thing here is from 6.2, rewrite this g of x, rewrite it in the form where you have some number, no x's, just some number over x minus h, and then plus k on the outside, and then graph the function. So I don't know if you remember, but this was either synthetic division or long division. Because this is a plain x minus 3, I personally would do the synthetic division. So we'll set the denominator equal to 0. So positive 3 is what goes in that top left box. The numerator is what makes me list these numbers, 2x minus 4. I didn't put my x, but they're in standard form from highest exponent to lowest. All right, so now the process for synthetic division. I bring down the 2, multiply by what's in the box, so 6, and then I add straight down. -4 plus 6 is 2. So this would turn out to be my remainder is always divided by the original divisor. I was originally dividing by x minus 3. So the remainder is still over the x minus 3. This part outside of the box there, this one's not the remainder, this one is the quotient. That's going to be your nice pretty whole number, 2. Okay. So this helps me kind of see any of the shifting up, down, left, right that we did. The +2 shifted everything up 2. So that will tell me where my horizontal asymptote is. Okay, so here's the +2 right here. And then the -3, again, I'm looking just at addition and subtraction. -3 tells me where my vertical asymptote is. This means I shifted everything to the right by 3. So I went to the right, I went in the positive direction. Pretty much all my x stuff does the exact opposite of what it usually would do with the y's. So there are the asymptotes. That kind of helps me figure out what numbers to plug in. I'm going to plug in like a little to the left of that vertical asymptote. So like 2, 1, 0, plug those in. On the other side over here, the x's that I think I'm going to choose are, again, right on the other side of the asymptote. So like 4, 5, and 6. Okay. All right, so let's see. What am I doing? I'm plugging in 2. Okay, so I'm gonna plug in my 2. I'm gonna get, let's see if you guys get the same thing as me. I think I got 0 there. With a 1, I got a 1. And when I plug in a 0, I got a 4/3. Messy fraction on that one. Okay, so I'm going to plot these points to make sure I didn't cross the asymptotes or anything. So 2, 0, 1, 1, 0, and then 4/3 is like 1.3-ish. It's like 1.3 repeating. So a little over your 1. Okay, so it's going to curve within the asymptotes. And then I'm going to plug in my 4, 5, and 6. All right, so my 4, I think it's 0.44. When I plug in my when I plug in my 5, let's see, 4 or 5.3, and when I plug in my 6, I think I get 2.6 repeating. So let's see if this works. 4.4. 1, 2, 3, 4. All right. 5.3. Okay. And then 6, 2.6 repeating, like a little below 3. All right, and it's in that top right corner. Okay, there we go. Not crossing the asymptotes, not even touching the asymptotes. Okay, so describe the graph as a transformation. And so I think I did the green one. That one was shifting to the right by 3. This +2 right here, as far as the transformation goes, this is shifting everything up 2. Okay. All right, there we go. See you guys later.